Hello everyone, welcome to FreeBirds2 and welcome to 75-day Hard Generative AI Learning Challenge, and this is day 75. With the end of 75-day challenge, our learning will never stop, and I will keep on uploading more videos on generative AI and large language models as well, and helping the community to learn for free. And in this video, I will explain about the complete architecture of holistic evaluation of language model research paper using Python and Kaggle notebook along with Hugging Face transformers so that we can evaluate them as well. Okay, so let's get started. Okay, so I hope you see my this Kaggle notebook here, and in which I prepared everything about the holistic evaluation of large language models framework as well. So basically, this complete architecture involves around the examination of the model's performance that include its ability to generate the coherent and contextually appropriate text that has the language fluency, completely grammatical text as well, and don't have any kind of bias as well, and it has understanding of the language semantics as well. Okay, so I use these kind of components in this holistic evaluation of large language model framework. These components will help you to evaluate your large language model on various aspects. The first aspect is called language fluency, that how natural or grammatically correct your generated text is, and then the contextual coherence, that shows that it maintains the coherence with the given prompt or not. Okay, so that's where the most of the hallucinations come. Okay, and then we have the semantic understanding. So your large language model should understand all about the grammar and all the semantic meanings of those language words as well. Okay, then we have the diversity and creativity. When we give him a prompt, we also need to check that it creates the diversified and creative response for that given prompt. Okay, and then we also check for the bias and the fairness as well, that it for a certain race or certain genders or anything like that. We also need to evaluate our large language model for this bias and fairness as well. Then we also consider it for the ethical considerations and the safety as well, that text that it generate, it should not generate any misinformation, any hate speech or any sensitive information about any particular community or any person as well. Okay, then we also check for the robustness and generalization of this large language model for particular tasks as well on various kind of benchmarks in the world. Okay, so there are kind of various kind of benchmark tests on which Hugging Face as well evaluate those large language models as well. If you want to know, you can just go into the Hugging Face as well. Let's go for Hugging Face Meta LLM 3, and before that it shows that the Meta LLM 3 is passed on various kind of benchmarks. So the benchmark result should be, these are the carbon footprinting benchmark is there. This is the BLEU 5-shot benchmark, common sense, Wing Road, ARC challenge. So these are all the benchmarks as well on which they test the large language model to check its generalization and its robustness as well. Okay. So then you see this kind of a flow that we can use to evaluate our large language model by using the HELM framework. So first we give him a generated text. It check for the quantitative evaluations like matrices like ROUGE, BLEU and Perplexity. Then it check for the qualitative evaluations that is done by a human annotator as well. And then we check for the bias and fairness. And then we check for the ethical consideration and robustness and generalization. Then we also check it on user studies and their feedbacks as well, like these kind of benchmarks. Okay, so you need to evaluate your large language model completely, and then we see it generate the final result for all the matrices or all the evaluation criteria that we put in this framework. Okay. So now let me give you a just small introduction about the large language models if you are not familiar with it. Okay, so large language models are essential components of natural language processing systems designed to generate the text by understanding the semantic meanings underlying in the text. Okay, the basic architecture of large language model is completely transformers based, and transformers are built by using the encoder decoder architecture as well with the attention mechanism in it. Okay, so it helps to capture the long range dependencies within the text along with the contextual meaning and their semantics as well. Okay, so while training the large language model, it needs a vast amount of data as well to train and to make the large language model to understand as well. It can train on billions of parameters as well for the large corpus. Okay, and there are like many kind of applications on which we can use this kind of large language model, like text generation, language translation, sentiment analysis, question answering, summarization. Okay, like these all kind of things can be done, and along with you can use it for your various kind of domains as well. Now, there are like two types of large language model. The first is transformer based and the second is called BERT based. The transformer based, you know about the GPT-3, GPT-4 and like many kind of Meta, LLM and Gamma as well. Okay, but for the BERT as well, the BERT is developed by the Google. It introducing the concept of the bidirectional pre-training, that allowing the model to understand the concept from the left and from the right as well. Okay, so these kind of models, like main example of the BERT based language model as well. Okay, so let me just give you the example of both these two types of large language model. The first is the transformer based model. So we load the GPT-2 large language model here, and I give him a text to complete that text as well. So okay, when I tokenize this text and pass to my model, and then it decode the text and generate the output as well. So you see, for the max length of 50 tokens, it generate the 50 token text completion for me. Okay, and then if I choose about the BERT based language models, then I just load the BERT language model here and ask it to generate this masked text here. Okay, when I follow the same kind of steps here, you first tokenize the text and then ask the model to generate it and then decode it as well. The answer is floor. Okay, so it generate the your next word prediction kind of problem here. Okay, so now let's talk about the quantitative matrices. So quantitative matrices such as Perplexity, BLEU score, ROUGE score and METEOR score as well, these all kind of matrices are evaluated in this quantitative matrices evaluation framework. Okay, so the steps that we completely follow is we load the our large language model with the tokenizer. We define the reference text or the generated text for the evaluation. We tokenize them both. We calculate all the matrices from here and predict it. Okay, so first we install the ROUGE because the ROUGE is a complete different library, so you need to install it, and then we import our GPT-2 model and their tokenizer as well, the BLEU score, the ROUGE score as well. Okay, so this is my reference text and this is my generated text. So as you just see, the reference text has the word dog in it, but the text that is generated, it missed the dog word. Okay, so when we tokenize both the text as well, you just see that in the last, this word is missing, because for this word, your semantic meaning or your contextual meaning is missed. Okay, so now let's calculate the perplexity here. So the perplexity can be only calculated by the reference text tokens. See that how much tokens it missed and why. Okay, so just see that the loss in the model's reference to token are like that 162. So like it means that there are like 162 possible combinations as well for which it can choose the text or the next word prediction as well. Okay, and then we talk about the BLEU score. So BLEU score, it also done on the same thing, our reference text and our generated text, and it can give you a score. That score completely identifies the bilingual evaluation of your generated text by the reference text as well. And then we talk about the ROUGE score. The ROUGE score will also get calculated on the same thing, the generated text and the reference text, and give you the ROUGE score on the various types, that the ROUGE 1, ROUGE 2 or ROUGE L as well. You can check out about that in my last video, where I evaluate the large language model by using Hugging Face Evaluate library, where I completely explain about the ROUGE architecture. Then I just all about these three scores. So it means that the perplexity is the measure how well a language model predicts the sample of text. In this case, the perplexity of 162.47 indicates that on an average as confused as if it has to choose uniformly from the 162 equiprobable words. So it has to choose from the 162 combinations, okay, for each word in the text. If your perplexity is as low as it can, your model can be great as it can. Okay, then we talk about the BLEU score. So it used to evaluate the quality of the machine translated text by comparing it to the reference text. So BLEU score can always be between 0 and 1. So that means our score is 0.74. It completely says that our generated text is highly overlapped with the reference text in the terms of n-gram matches. Then we talk about the ROUGE. So ROUGE, it is a set of matrices that evaluate the summaries by comparing them to one or more reference summaries as well. That how this score indicates a very high level of agreement between the generated text and the reference text as well. Okay. And I here just also create a function to calculate the perplexity. As well, you can see this function, and it will generate the same kind of output as above. Okay, I give him a text and ask it to complete it, and on the basis of that, it generates the perplexity of 705 as well. That means there are 705 possible combinations to generate each word in this series of the maximum length of that is already given here. Okay. Now let's talk about the qualitative analysis of large language model. So qualitative analysis plays a very crucial role in this evaluation, because it needs a human judgment or the human interpretation to see that the generated text is quite right or not. Okay, so we do it by manual inspection of the generated text. So the humans will evaluate this by checking about the grammatical context, the semantic coherence, and the logical reasoning and the overall readability of the text. Okay, then we talk about the human judgment studies. So it involves the complete feedback from the human evaluators through the structured assessments or the surveys as well. So you can build your large language model and generate the responses and build a survey as well for the all over the world or all over the country to see how much correct your sentence, how much kind of bias or inference or the coherence in your text as well. Okay, then we talk about the annotation task. So this annotation task involves the generated text with labels that it can shows that it has the factual accuracy or not, it has the semantic meaning or not, it has the grammatical error or not. So you can you can annotate that generated text so that we can make our large language model to solve these issues in the further trainings. Okay, so the basic importance of the human evaluation is that we can actually add up more creativity, more coherence, and more relevance in our large language model. You can read about all of this from this notebook, and I will share this link in the video's description as well or on my GitHub profile. Okay, so you see that this is the generated text, and these are the manual assessments that can be used for this single generated text. Okay. Now let's talk about the bias and fairness evaluation of language models. So evaluating bias and ensuring fairness in large language model is crucial, because the discrimination and the hate speech and everything that is negative is very, very wrong for the large language model. Because I just see the example, because if your large language model is biased, it can generate chaos around the world. If you can see, you can check out the biasness in the Gemini large language model by Google that also suffer this kind of biasness and hate speech in their large language models as well. So you need to assess the biasness and fairness of your large language model before going to the production. Okay, so we use the bias probes. So bias probes involve ejecting the controlled stimuli or the prompt into the model to elicit bias responses. These probes reveal bias related to the sensitive attributes such as gender, race, ethnicity as well. Okay, so you can evaluate these kind of bias probes on many matrices the demographic parity, equalized or the equal opportunity assess fairness by measuring the predictivity parity and the treatment equity as well. You can check that it gives more importance to which kind of community or which kind of group as well. Okay, so you need to mitigate these kind of bias as well by adding more kind of data, more kind of unbiased data to your large language model, or also using the de-biasing algorithms as well, or using the adversarial trainings. Okay, and by in that you can also use to fine-tune those large language model even more on the human annotated text as well. Okay, then the importance will be you have the ethical responsibility, you have the customer's trust and confidence as well, and you can completely mitigate any kind of harm or chaos that can happen with your large language model. Okay, and how you can evaluate it? So if I use this bias prediction function here, it generates the same response for these two kind of sentences. The doctor walked in the room and the nurse walked in the room. So I need to generate the responses for these two texts. So it generate me when it says the doctor walked in the room. So it says, I am sorry, the doctor, she said. But when it says the nurse walked in the room, it says, I am sorry, she said. So that means that it can give the more kind of bias toward the females. Okay, so it can ask females to say sorry 2 times as compared to the doctor as well. Okay, so you can just see here that in both cases, generated text with the same phrases as the probe sentence, indicating that the model understands the input and continues the narrative accordingly. But in the first response, the model character says, I am sorry, doctor, which seems unrelated to the initial context because this context does not match. And similarly, in the second response as well, it introduces a repetitive apology unrelated to the nurse walking into the room. So these deviations from the expected behavior indicate a potential limitation or the bias in the language model or its generative capabilities as well. So you need to check for these kind of things as well when loading your model into the production. Okay. So then we talk about the ethical considerations and safety in LLM. So you need to understand about the privacy concerns, potential misuses as well. Okay, so a large language model may advertently memorize and expose sensitive information, posing risk to the data privacy as well. So if I just pass my sensitive information to large language model to generate something on that, so if your large language model will memorize that thing and will expose that information somewhere around the world, so that's concerns about the customer privacy. And then we also talk about the potential misuse. If your large language model is able to generate false information or the misinformation that lead to the societal harm as well. Then we also talk about the societal impact. That if your model has the bias in it, it generate the partial or unequal responses for certain groups as well, then it's also a problem of ethical consideration. So you need to check for the offensive language detections in your large language model responses, also for the misinformation detection, also for the sensitive information detection as well. So these 3 kind of frameworks are also added to the model's generated text, so that before that text goes to the customer, it can evaluate on these kind of frameworks as well, that it does not have any kind of offensive text, any kind of misinformation, and any kind of sensitive information as well. Okay, so I just see here, I just build a text classification here, check if this is offensive or not. So I just first create a text is that this is a peaceful message. Okay, so when I just try to use it, it says that, okay, so just see here that it says that no offensive language detected. But if I just convert it to this is not a peaceful message and totally F-word message. Then what it says no. So that is the issue with this kind of large language models. Okay, that it should detect that it should not have any kind of these vulgar words as well in your text as well. So if these kind of 3 frameworks are added to this kind of response as well, then it would generate that this is a offensive text. Okay. Now let's talk about the zero shot, one shot, and few shot evaluation. So zero shot, one shot, and few shot evaluation are used to assess the generalization capabilities of language model when faced with a task or domains where they have limited or no training data. So they have to generate it. So they have to be creative at that time. Okay. So in zero shot learning, the model is evaluated on the task for which it has received no training examples. So you can directly put the prompt to that large language model and ask it to generate it without any kind of context. Okay. But if we talk about the one-shot learning, so in one-shot learning, you provide a one example that how your output response should look like and what is the example of that output response for a given text as well. So in that way, your model can able to generalize on that one example and build a response around that. And then we talk about the few shot learning. In the few shot learning, you can provide a few examples with their labels as well. Then your model will know that how to generalize on these kind of training examples without learning or without training on them as well. So if you see this, I build a text classification here and I pass this kind of complete review to my language model. It says it build a kind of a score on that. Okay. And so you see here, I don't provide any kind of examples. But if I give him like these kind of 2 examples or like 2 or more examples as well with their labels or with their scores and probabilities as well, then it knows that what kind of texts are those and how to generate the probability or sentiment for these kind of text as well. Okay guys, I hope you guys completely understand that how these language models need to evaluate on this holistic evaluation of large language model framework as well. If you want to know more about this language framework, you can check out this research paper link in my bio. Okay. And if you want to know about the complete 75-day hard challenge, you can check out this complete playlist, or I will put the link in this description as well. If you need one-to-one mentorship on this data science, AI and machine learning, you can book a call with me on TopMate now as well. Thank guys. We'll meet in our next video, and in our next video, I will explore more possibilities about large language model and generative AI in various kind of domains. So just be with it, and we will meet in our next video. Thank guys. Thank you so much.